So in this video, I'm going to talk about acceleration. First, let's define what acceleration is. Acceleration is a change in velocity. And so it describes how quickly it changes its motion. So the motion can be either changing the speed, that you're actually going faster, starting to go faster, or starting to go slower. So the change in speed and or change in direction. So you can just be moving and change the direction. That's also change in velocity. And acceleration describes both changing velocity and changing velocity. So therefore, changing speed and changing direction. Let me write this down. So acceleration. Acceleration is a change in velocity, how quickly velocity changes. So, acceleration. How quickly describes how quickly and in what direction velocity changes. So how fast you move from, so that let's imagine you have a Porsche versus bicycle, right? To come from rest, you're at the red light, and then when you want to speed up, they may both go into, Porsche doesn't have to go that fast on a surface road. So they can both, the initial speed of a bicycle and a Porsche is the 0, it's at rest. And then the traffic light changes from red to green, then it moves forward. So the velocity, maybe the speed may change from 0 to, let's say, 10 miles per hour. But with the case of bicycle, it may take 30 seconds to reach the 10 miles per hour. But for the case of Porsche, it may reach to 10 miles per hour in 2 seconds. So final and initial speed is the same for the bicycle and a Porsche, but how quickly it can reach to that final speed is different for the Porsche and a bicycle, right? So that means that Porsche went through, what is it, bigger or same or slower acceleration compared to the bicycle? Porsche went through bigger acceleration than a bicycle, although their changing speed is the same, but how quickly it went to that speed is a lot shorter in time for the Porsche. So Porsche had a bigger acceleration. So acceleration, if I want to say acceleration is a change in velocity, but how quickly changes its velocity? How quickly changes velocity? Velocity changes. And here velocity can be both the speed and then both the direction. So if I were to write it in how to quantify acceleration equals to change in velocity divided by how long it took to change that velocity. for that time interval. And the unit of a velocity, do you remember? What's the unit of the velocity? It's meter per second. And the time, we use second. So therefore, unit of acceleration, we use meter per second square. Let's say that you're moving forward towards the camera, right? You're moving forward with 5 miles per hour or something, or you're moving 10 centimeter per second or something, moving, right? Coming towards the camera. And then let's say you go under the acceleration of 5, you're moving 10 centimeter per second. Let's say you have an acceleration of a 10 meter per second square. What would that be your, and then you have the acceleration for 10 meter per second square for a second, 1 second. So what would that be your final velocity? Let's say Porsche went through the acceleration, it's okay. My finger went through the acceleration of 10 centimeter per second square, right? But how to describe the motion? Is that a good enough information? Because the acceleration can be actually in the same direction. How about the 10 centimeter per second square is happen in the opposite direction. So the acceleration is the opposite direction to the motion. Then what happens to the speed and the velocity? You slow down. If it's in the same direction, you speed up. What if it's happening perpendicular to the velocity? You would turn, right? So acceleration here, the change in velocity, which in this case is correct definition, but if we just talking about changing speed per time, that's not enough information. We need to consider the direction relative to the motion. If it's parallel to each other in the same direction, you have an increasing in speed. If you have it in the opposite direction, it's gonna slow down. When it's in angle, then you're gonna turn either to the right or to the left, right? So acceleration, would that be a velocity or scalar quantity? Right, so velocity is a vector quantity, and we're talking about change in velocity. So acceleration is also vector quantity. So acceleration is vector. And that means it both describes changing velocity, right? Changing velocity. So it's not just changing speed. So acceleration describes and or change in speed, change in direction of motion. So when you could be moving and then acceleration is happening with the angle to your motion, right? It's not parallel or anti-parallel. If you have an angle, then object would turn. So you have a change in direction. If it's in the same parallel component, if it's in the same direction, speed up, opposite direction, slow down. change in velocity. So let's see. This case, I'm going to bring this guy up. Let me see. Copy. So they're in a car. Right? It could be moving with let's see, this direction, huh? This is the initial direction of a speed. Let's say they're moving with 3 meters per second. In order to slow down, draw the acceleration vector to slow down. Let's say acceleration vector. So to slow down the acceleration vector. So the slowing down acceleration vector has to be anti-parallel to the initial velocity, right? It has to you have an acceleration changing velocity in a backward direction. So the acceleration when A is 2 meters per second squared in the opposite direction, then that means that B final let's say for 1 second. If it's applied for 1 second, then the B final will be in this, it's still going to be in the same direction. But in this case, it's going to be 1 meter per second. So you slow down for 1 second, you press the brake, 2 meter, that gives the acceleration 2 meters per second squared in a backward direction for 1 second. Then your speed changes from 3 meters per second to 1 meter per second. Initial velocity and final velocity. So I hope you see that example. If you have an initial velocity, right? If you have an acceleration in the same direction, is it going to be speed up? Down? Or the constant? What happens if you have a VI and acceleration in this way? To the speed. Speed is going to be up, speed up, or down, or constant. What happens if you're moving in this direction, but acceleration is like this? Does the speed change? If it's completely perpendicular, direction, what happens to the direction? Turn right, left, or straight line? Same thing here. When you have it, the direction, what happens to the direction? Turn right, left, or straight line. Same thing here. Direction, right, left, or straight line. So each case, can you describe the motion? Then, what if this way? The most difficult example, more difficult one. You have initial velocity. Let's put the acceleration like this way. This is the acceleration. Described as change in speed. Speed up, down, or this constant in a direction. Turn right, left, or straight line. Maintain the same direction, staying in line. So I want you to circle for all of these cases and find out how A is the acceleration that describes the change in velocity. Let's see. So here, I'm gonna, should I put the word in here? I could do this. Okay, so here, I think the girl in a blue dress is easier to see, but you can also look at the boy too. So let's see, what kind of a motion is this? Are they in a constant motion? Constant motion means constant speed and in a straight line. Or are they speeding up, slowing down, or turning? What is the acceleration?
はい、歩いて。早く歩いて。はい、Thank you.
What do you say? Do you think that the acceleration, so is that a increasing speed, decreasing speed, or maintaining the same speed? Or did they turn, right? They went forward in a straight line, rather straight line, and they sped up. So the acceleration is in the same direction as their speed, initial velocity. So acceleration is positive. So when they're in the same direction, acceleration is positive. Positive. They could be moving to the left or right? But then it's in the same direction, positive, means speeding up. But then if they're in the opposite direction, then slowing down, it's negative. But they could be moving them. It's all relative to the velocity. The velocity could be up or down or right or left towards you or back, right? You could be moving in any direction, but all you care is the acceleration vector that's relative to the velocity. Let's look at this case.
Hi, ゆっくり。はい、ありがとう。
Right? So what is it? Acceleration vector, is that a positive, negative, or it's in an angle to the velocity?
はい、ゆっくり。はい、ありがとう。
Acceleration vector is negative. They slew down. It didn't seem like they changed the direction, right? So that's one thing. How about this? This one.
ゆっくり。早く。
One more time. So,
はい。ゆっくり。早く。
is in this case, is acceleration constant?
はい。ゆっ
She
くり。
slew down, so acceleration was negative to the
早く。
motion. And then now there's the acceleration became positive to the motion. She sped up. So acceleration wasn't constant. It changed the direction. Was it slew down first and then sped up, right? So it went to the motion was, let's say it's this way. It was in the opposite direction to the motion and then became in the same direction to the motion. Okay, again, it's always just relative to the motion. How about this one? So I asked them to go with the same speed, maintain the same speed. So they did their best to try to maintain the speed. The boy wanted to go faster, but I think, they're trying to maintain the speed. But so if the speed is the same, does that mean that the acceleration is 0? They're going around and around and around, right? Let's see again.
Hi.
They're going around and around and around. Even though it's the constant speed, let's say steady speed around and around and around, but to go around, you have to keep turning, constantly turning. So is acceleration 0 or non-zero? To be in the same constant speed, what is the direction of acceleration relative to the velocity? Okay. Let's go back on this one then. Okay. Oops. Right? So let's do this first example. If you have a velocity that's pointing upward and acceleration is in the same direction, so acceleration is parallel, right? This acceleration here, this one is a parallel to the velocity is positive. So the speed will be speeding up. How about the direction? There is only a parallel component. Is there a perpendicular component? So any perpendicular component to the velocity, that's 0. What it means here is that we have, let's say you have a velocity, and then I write out a like this, a vector. That means I can decompose this a vector. This is going to be a perpendicular to the velocity. This is going to be a parallel to the velocity. V could be pointing in this way. And then if A is going to be pointing in this way, then This is going to be parallel component. A parallel, A perpendicular. All right. And in this case, it's negative. A parallel is pointing in an opposite direction to the B. Okay. So knowing these two examples, okay. First example, we have a perpendicular, okay, this one, A perpendicular to be 0. So A perpendicular is 0. So there is no perpendicular, A perpendicular acceleration that's perpendicular to the velocity implies the change in direction. And there's no perpendicular component. So it's going to just move in a straight line. It doesn't turn. It's either there to speed up or slow down. And A parallel component describes the change in speed. And in this case, it's positive, so it's speed up. Let's look at this case. In this case, A perpendicular component is 0, right? There's no perpendicular component, but A parallel is negative. It's pointing in the opposite direction to the velocity. So since the A perpendicular is 0, so there is no turning. It's going to be in a line. And when A parallel is negative, so acceleration is pointing in the opposite direction to the motion, so it's slowing down. Let's look at this case, the third example. Third example sees, you see that A parallel component to the motion is 0, but A perpendicular is pointing to the right to the motion. Then the parallel component is not either in the same direction nor opposite direction. So it's going to be in the same constant speed. However, so if you don't have any parallel component to the motion, speed is constant. However, when it's pointing, there's a perpendicular component to the motion, and the motion is this way, and then it's pushing to the right of the motion, so it's going to turn right. That's going to be the answer. All right, so let's do this example. And I may not show all the way. I want you to figure this out. First, let's decompose this A vector into the parallel to the motion and a perpendicular component to the motion. The motion I'm talking about is this. This is the motion. So it's moving in this direction, a little bit northeast, northwest, right? On the paper. So if I want to decompose this A vector into parallel component, that's going to be parallel. This looks like a parallel, right, to the motion. And then this looks like a perpendicular to the motion, I think. So this is going to be A parallel, which is pointing in opposite direction. And this is going to be A perpendicular. So what do you think? Is it going to be speeding up, speeding down, or staying constant? Is there going to be any change in the direction of motion? Is it going to turn right or turn left or staying in the same line? So I want you to work on this problem, and then you can confirm your answer in a discussion. Okay. So again, to find out the acceleration is the change in velocity. Change in velocity. I'll write it first. Acceleration is a change in velocity per time. How quickly you change the velocity. So acceleration is a vector. It's a vector, and then the velocity is a vector. Is time a velocity? Is time a vector or scalar? Time is a scalar component, right? So the acceleration is parallel to change in, oh, I'm sorry, I keep writing this thing without really saying it. So here, this delta, this thing is called Greek letter, looks like a triangle, Greek letter delta. And it describes change. So when you write change in time, this means change in time. This means t final minus t initial. So this one can be rewritten as change in velocity divided by change in time. Therefore, acceleration, and again, the time is a scalar component, but acceleration and velocity, they're both vector component. So the direction of a change in velocity should be parallel to the direction of acceleration, because time is just there to change the amount. So they should be parallel. The direction of a change in velocity should be parallel to the acceleration. Vf minus vi, right? So let's say if I have an initial speed, that's initial velocity that's moving in this direction, let's say, v initial. And then, but this object later on turn into this direction. Vf minus vi. So Vf minus Vi, that's equals to, right? Then you make a parallelogram. This is going to be change in velocity, which is Vf minus Vi. Okay. So acceleration, we don't know the amount. It might not be this much, but acceleration is going to be parallel to Vf minus Vi. So it's there to change the direction. And the amount is going to be depend on the time period, how quickly it moved, it changed that. All right, so something like that is going to be the acceleration, but please try to be able to do this, right? Again, to speed up. So if you have a initial velocity this way, acceleration in this way, speeding up. Initial velocity in this way, acceleration in this way, slowing down. sorry, A parallel is positive, A perpendicular is 0. A parallel is negative, A perpendicular is 0. And then if you have, okay, in this case, you have A parallel is 0, but A perpendicular is pointing to the right. So in this case, it's constant speed turning. Right. Turning right. A is like this. A parallel again. Sorry. A parallel again is 0. Oops. 0. But A perpendicular is to the left of the motion. So in this case, constant speed, but turning. And you're just going to decompose every time you have a V and then A, you're going to decompose relative to the motion. This is rather perpendicular, this is that. So this is going to be A perpendicular, and this is going to be A parallel. So is this case speeding up, slowing down, constant speed, or turning right, turning left, or moving in a straight line? What is the motion? All right, so make sure that you can do this decomposition and also understand this change in velocity thing and understanding velocity acceleration. All right. So this is going to be the end of this video of acceleration, and I'll see you in a discussion.